Okay, so the first step is to factor these. So let's factor our numerator. How do we factor x squared plus 7x plus 10? What are we looking for?
The things of 10 that add up to 7.
The things of 10. Fingers? What do we call those things, Jillian? Factors. Good. So we want the factors of 10 that add up to what number? 7. And what are the factors of 10 that add up to 7? 5 and 2. Good. So that becomes my first pair of factors. X plus 5 and x plus 2.
Is that division?
Yes. Just like the problem.
Yeah, sure.
Okay, how about the factors of negative 10 that add up to negative 3? Negative 5 and positive 2. Good. So x minus 5 and x plus 2. Very good. Okay, so that's step number 1. Now, we're going to see different ways of factoring, but generally speaking, step number 1 is to factor.
So that was just step number 1, factoring out the numerator.
Correct. Okay, step number 2 is to cancel. What do we cancel?
The 2's.
Why can we cancel these 2's,
Because
Jillian?
they're exactly the same, so they're
Well, but why?
because you're
What is x plus 2 divided by x plus 2?
1.
1. So that's the next step, is to look for 1s. Look for places where the numerator and the denominator are identical, because you can cross them out because the quotient is 1. So I can cancel out my x plus 2's, leaving me with x plus 5 in the numerator and x minus 5 in the denominator. So that's step number 2.
I thought you were supposed to cancel the opposite side.
No,
Why?
because they're not the same.
Alright.
What you're doing is you're dividing here. So if you want to divide something that adds up, that divides to 1, has to be the thing divided by the same thing.
Positive 5 divided by negative 5.
But you're not dividing positive 5 and negative 5. You have x plus 5 and x minus 5. You can't divide them together. You can only divide stuff separately when you're multiplying, which is what allows us to, because now we have multiplication. That allows us to divide out the x plus 2 and the x plus 2. This is now x plus 5 and x minus 5. I can't separate this into x and 5 and cancel out the x, and then cancel this out and make negative 1. It doesn't work that way. That's not how math works. Okay, so step number 3 is to list the restrictions. Well, what's a restriction? A restriction in math, in these problems, is some value that makes the denominator equal to 0. Now, why would we want to look for that? Why do we want to look for numbers that make the denominator equal to 0?
Because then you're just left with 1,
But what do you mean by that?
because then you're not left with a fraction. You're left
You're allowed to be left with a fraction. But there's something prohibited about having a 0 in the denominator. What?
with the numerator.
No. What happens when you try dividing by 0? No. It's impossible. Like skiing through a revolving door. Can't divide by 0. It's against the laws of math. You can't. So what you need to do is you need to look for those values that make the denominator equal to 0. But here's the catch. This way.
Sorry, sir.
The catch is you can't just look at your final answer. What you really want to look at is you go back to the original problem. Now, since the original problem doesn't really lend itself to finding stuff that makes the denominator equal to 0, what you want to do is you want to look at your factors. Because if you look at your factors, it's very easy to pick out the values that make the denominator equal to 0. This one is really, really easy. What minus 5 equals 0? 5. So one of my restrictions is that x cannot equal 5. Well, that one's obvious because it's still here in the denominator. But the one you have to be careful about is the other one.
Is it imaginary?
No.
Oh.
It's, you look at this factor, even though you've canceled it out, it still was a part of the problem. So what value makes x plus 2 equal to 0? Negative 2. So my other restriction is negative 2. Now if you go back, if you want to check your work, go back to the original equation, or expression I should say, plug in negative 2. Negative 2 squared is 4. Negative 2 times negative 3 is positive 6. I get 4 plus 6, which is 10. 10 minus 10 makes 0. And you cannot divide by 0. Sir,
Sorry, where did you get the negative two from?
I looked at my two factors.
Right.
What value here makes x plus 2 equal 0? What
Yeah,
plus
negative 2, but what happened to the positive 5? How was it supposed to be?
Yeah, it's also a restriction.
Yeah, so,
Both. X can't be either one of these numbers. If I let x equal 5, I get 0 in the denominator. If I let x equal negative 2, I get 0 in the denominator.
oh, so we're not done yet.
No, now we're done.
We are.
Yes,
So what if x were to equal negative 5?
doesn't matter. Negative 5 doesn't make the denominator equal 0.
So the answer is 5, negative 2
This is the
5.
end. This is the x plus 5 over x minus 5 is this thing simplified.
Okay.
But x cannot equal 5 and x cannot equal negative 2. Because if you plug in those values for x, it's going to make the denominator equal to 0.
We're doing another one, right?
Yes. Okay, are there any other questions? Okay, so let's take a look at another type of problem that you're going to see. And now we don't have trinomials, but we have monomials. But we're still going to do the same thing. Now we don't have to factor. Now we can go straight to step number 2, which is to simply divide. So we're going to divide our number by our number. So 24 divided by negative 6, negative 4. I have x to the third divided by x squared. What do you do with your exponents when you're dividing and the bases are the same? Subtract. So I get 3 take away 2 leaves me 1. So I got 1x up here. Now here I have y squared and y to the third. What's 2 take away 3? 2 take away 3 is negative 1. So where should I put my y? At the top or at the bottom? I put my y at the bottom. I could put it as y to the negative first and put it on top, but then I only have to go through the process of moving it to the bottom. What you want to do is just see which number is greater to start with, and that's where your value is going to end up. So since 3 is greater than 2, I know that my answer is going to end up in the denominator. And here, since the numerator is greater than the denominator, my answer ends up in the numerator.
And then, are there any restrictions?
Of course. Y cannot equal 0. And how about x? Go back to the x cannot be 0. That's right. So my restrictions are x cannot equal 0 and y cannot equal 0. Remember, don't go by what your final answer is. Got to go back to the original problem. You got to ask yourself, what's the value or values for each of the variables that's going to make the denominator equal to 0? Well, if I want to make a string of numbers that I'm multiplying add up to multiply to 0, what does one of those numbers have to be? One of them has to be 0. So if I let y be some value, then x has to be 0. If I let x be some value, then y has to be 0. That's where we get the restrictions from. Okay. Let's keep going. Now, this is now another kind of factoring. This is where we look for, at least in the numerator, we look for the greatest common factor. Yes,
Future, bro, future.
GCF. Okay, so what's the GCF of 12 and negative 4? 4. Good. So I'm going to factor out of 4. So what does that leave me with? 12 divided by 4 is 3. Bring over my sign. And then 4 divided by 4 leaves me 1. And then I have this leftover n. So I have 3 minus x. Now, does anybody recognize what that is?
That's on the thingy where you like distribute it and then
It's that thingy.
I don't know.
This is a special kind of binomial. What do you notice about the first term and the last term? Josue?
Perfect time.
No, it's not a trinomial because there's only 2 terms. So it's a binomial.
Binomial.
It's the what? It's the difference of 2 what?
Perfect square.
2 perfect squares. Who remembers how to factor the difference of 2 perfect squares?
You want the what's the
I'm going to suggest that your college major not be
Oh.
communications.
root?
Do you do x plus 3x minus 3?
You do.
Yeah.
Square root of the first term, square root of the second term, 1 plus 1 minus. Okay, we've hit a snag. Because if we can't cancel something out, it means we haven't done our job. So there's something screwy.
You have to
About what
distribute
we've
your
done.
form.
If I distribute to 4, I'm going to go right back to what I started with. So no, I don't want to distribute to 4. Josue?
Quick question, sorry. Wouldn't the blue be a negative?
Which 3?
The one next to the x.
Why?
Was your
What did I divide?
nothing?
I divided nothing? Okay. Clearly, these look close. Don't they look close?
Yes.
Unfortunately, in math, close doesn't count. So, we can do that. How do we do that? How do we go ahead and change the signs of this? What can I multiply or divide by negative 1? So, as a matter of fact, you can go back and instead of dividing by 4, now you can go back and say, maybe I should have divided by negative 4. Because now if I divide by negative 4, I get negative 4 on the outside. You get negative 4 on the outside. Now what's 12 divided by negative 4? It's negative 3. And then negative 4 divided by 4 gives me positive x. Okay? Now, notice how I didn't notice right away that it should have been negative 4. So it's okay to go back and redo it once you realize what you should be doing. Because it is confusing when you start. You don't know when you start that you're going to be factoring out the negative 4. So it's okay to factor out the positive 4, which makes logical sense. But then when you get to the next step, recognize maybe I should try. If you don't get anything that matches, it means you've made a mistake. So in this case, the mistake was dividing by 4 and not negative 4. Now, I can rewrite this. If I put the x in the front, what do I get if I just rewrite this with the x in the front? I get x minus 3. So now I get x plus 3 divided by x minus 3. My x minus 3's cancel out. I'm left with negative 4 over x plus 3. What are my two restrictions? Remember, we don't look at the final answer for our restrictions. We look here. We don't look at the numerator at all. For restrictions, we don't care what's in the numerator. Let me say that again. We don't care what's in the numerator. We only want to know what's in the denominator. So what are the two values for x that are going to make the denominator 0? 3 and negative 3. So my restrictions are plus and minus 3. And again, when you're working on these problems, if you do not include the restrictions, you have not done your job completely. Because let's say you're an engineer and you want to send guys to Mars. If you tell them to include a value that puts a 0 in the denominator, you're not going to end up in Mars. You're going to end up dead. You don't want that on your conscience. Later finding their death amusing. Okay, does anybody have any questions?